Hello, in this video we will provide you with information about an exciting new math technology initiative that will be implemented in SAISD next fall. The study From Here to There, a dynamic algebra intervention for improving algebraic understanding, is funded by the U.S. Department of Education. Our teams at Worcester Polytechnic Institute and Westat will be collaborating with SAISD to better understand how students learn algebraic concepts and to help improve math learning for your students. The San Antonio Independent School District intends to have all 7th grade students and math teachers from all middle schools in the district participate in this math initiative during the fall of 2019. We are excited to partner with principals, teachers, and students in this collaborative work. The goal of this project is to learn more about how technology can be used to help students learn challenging mathematical concepts and engage in problem solving. Students will practice solving math problems related to numbers and operations, computations, and algebraic relationships using one of 3 research-based interactive math technologies: From Here to There, Dragonbox, and Assessments. The content is aligned with the Texas Essential Knowledge and Skills and focuses on many of the topics that students will be learning this year. It also addresses many of the gaps in math skills that students have when entering 7th grade. Students will complete these engaging activities online in their math classes across several months. There is no cost for schools, teachers, or students to participate, and teachers will be compensated for their participation. Despite significant efforts to improve mathematical understanding, a majority of students in the U.S. struggle to reach proficiency. English language learners fall even further behind, likely due to the high amount of language required in mathematics instruction. While math experts are able to make sense and extract patterns within mathematics, the symbolic notation presents many hurdles for students learning algebra. Interventions and technologies that help students attend to the visual patterns available in notation may help them become more engaged, flexible, and proficient problem solvers, see patterns, and form connections in mathematics. In a prior research grant from the U.S. Department of Education, we developed a dynamic math technology From Here to There that turns mathematics notation and symbols into interactive virtual objects that react according to their mathematical properties. In From Here to There, students transform math expressions by picking up, dragging, tapping, combining, and breaking apart parts of the equation on the screen and decomposing numbers into equivalent expressions. From Here to There has 14 worlds that focus on different math concepts ranging from addition and multiplication to balancing and solving equations. Each world contains 18 problems that start simple and build in difficulty throughout the game. In From Here to There, each problem has a starting expression and a goal, and the objective of the game is to transform the starting expression to match the goal. This self-based, puzzle-based style encourages play, flexibility, and creative thinking. The problems in From Here to There have multiple paths to the goal state and are designed to promote flexibility and creativity with numbers. The system provides a safe space for students to explore the mathematical properties using multiple strategies. If students try something that is mathematically incorrect, the system will provide feedback shaking the expression. If their action is correct, it will transform the expression. Instructions and videos are provided throughout the game to show students how to use the system. Students may restart the problems as many times as they need to and request hints when they need additional support. If students have difficulty remembering the gestures, they can go to the gesture library by clicking the question mark and review the gestures that they have learned so far. Research has shown that From Here to There is easy to implement in a classroom and can increase student engagement, motivation, and math learning. Further, lower performing students make the greatest gains when playing the program. Results also indicate that the gamification elements of From Here to There increase engagement with problem solving. The study tests 2 research questions. First, does From Here to There produce gains in students' mathematical understanding compared to 2 other technology-based conditions and a control? Second, does From Here to There help certain students more than others, including lower performing students or English language learners? We are also interested in using the data from the study to understand how perceptual learning technology can improve mathematical understanding. Participating in this study is simple for teachers and students and can be completed in math classrooms on devices or in the school computer lab. In August, 7th grade teachers will attend a 2-hour professional development training to learn about the project implementation and the 3 technologies. Once we receive classroom rosters from SAISD, our team will create individual accounts for students and assessments and will provide the login information to the classroom teachers. Classroom teachers will then dedicate 30 minutes each week to this initiative. All students will log into assessments, click a link, and spend 30 minutes solving problems on their assigned technology each week. All assignments will be pre-loaded onto their accounts. In each session, students will log in on the website, click a link, and spend the 30 minutes working on the activities on devices or computers at school. After 30 minutes, a timer will notify students that they are finished for the day. Teachers can also log in to monitor which students have not started or completed an assignment. No grading or changes in classroom instruction is required for teachers. However, teachers can always engage with students while they are solving problems. All students will be randomly assigned to one of the 3 technologies used in this study: From Here to There, Dragon Box, or Assessments. The students assigned to the From Here to There condition will play through the game described earlier. Another group of students play the Dragon Box game for 30 minutes each session. Dragon Box 12 Plus is an award-winning popular educational game that is known as one of the best educational games for mathematics and algebra teaching and learning. Dragon Box introduces players to algebraic concepts through discovery-based puzzles that use motion and animated characters and symbols to practice algebraic concepts. It also uses gestures, multiple representations, and immediate feedback. In this game, students move pictures and symbols in a way that resembles the rules of algebra. The game has 10 chapters with 20 problems in each. Each chapter focuses on different mathematical concepts. New concepts are introduced at the beginning through pictures, and students apply the concepts to the algebraic symbols. Throughout the game, the pictures are gradually replaced by algebraic symbols. As students work through the game, the puzzle gets increasingly complex, requiring them to apply multiple mathematical properties and skills. They also acquire new powers that can help them with more difficult problems. Students can track their progress by checking the number of stars earned per problem, per chapter, and throughout the game. Students will also be asked to reflect on how the actions that they learned connect to mathematical concepts. Remaining students will use the Assessments technology. Assessments is a free, research-backed online tutoring system which has students solve math problems well aligned with the standards and provides both immediate and delayed hints and feedback. Assessments has recently been named one of the most effective educational interventions for improving math learning by the U.S. Department of Education's What Works Clearinghouse. Students in this group will complete problem sets that cover content from numbers and operations to substitution and linear equations. The problems are selected from 3 commonly used middle school mathematics curricula: Engage New York, Utah Middle School Math Project, and Illustrative Math, and are all representative of the problems that students commonly solve in the classroom and during homework. Assessments will provide students with the problem, and then the students will be asked to enter their answer. Half the students in this group will have hints and worked examples available during the problem and receive immediate feedback on their answer. Partial credit will be given based on the number of hints requested and the number of incorrect answers submitted. The other half of the students will solve the same problems but will receive correctness feedback after they have finished solving the entire problem set. This delayed feedback procedure mimics the timing of feedback students usually experience in a typical classroom. After spending 30 minutes on the problem set, both groups of students will receive a report that shows their performance on each problem. Students will see their answer and the points earned for each problem. They will be asked to revisit problems that they answered incorrectly, think about their answer, and work through the problem again. Hints and the correct answer will also be available. In order to better identify gaps in student knowledge and areas of growth, it is important to assess learning over time. During sessions 1, 6, and 12, all students will work on common assignments that assess their understanding of equivalency, equation solving, and other algebra readiness skills. They will also answer some questions on their feelings towards mathematics. Teachers will dedicate 1 class session a week, 30 to 40 minutes, for 12 weeks in the fall, September through December, to this initiative. Each activity aligns with the standards and expands upon the concepts practiced in the previous assignments. Students will also complete one additional 30-minute spring session after STAR testing to measure learning and growth during the school year. Previous research has shown that the use of mathematical technologies can increase student engagement, motivation, and mathematical understanding in a way not provided through traditional instruction. Benefits for students include quick feedback, increased engagement and motivation in math topics, flexibility in problem solving, decreased math anxiety, and increased efficacy. There are several benefits to teachers and schools as well. Teachers will be able to easily integrate new research-based technology interventions and tools into their classrooms that align with the Texas standards and give ample opportunities to address common errors and misconceptions. A teacher trainer will be available throughout the study to help answer questions as they arise. The results from this project will help teachers and principals at your school by assessing and identifying common challenges that your students have. Findings from our work will be shared with SAISD and national audiences that will help your school reflect on student math knowledge and classroom practices that support mathematics teaching and learning. After the study, SAISD will receive full access to the full From Here to There program, a teacher dashboard that provides student data, and professional development opportunities for 5 years. This study has been approved by SAISD's Research Office and Parent Board and does not require parental consent. A letter will be sent home to all parents in the beginning of the school year that describes the study and gives parents the option to opt their child out. In these cases, math assignments will be determined by their classroom teacher and no data will be recorded from our team. If you have any questions, you may contact Dr. Erin Ottmar, the project leader at Worcester Polytechnic Institute, or Nancy Hartman at Westat, an education research firm in San Antonio. Dr. Hartman will work directly with SAISD, providing technical assistance to teachers during implementation, as well as serving as the primary contact. Thank you for your attention, and we look forward to working with students and teachers at SAISD.